Welcome to my presentation on artificial intelligence. Let's get started and see what I can show you about what artificial intelligence is. So let's start by talking about what AI is. And in simple terms, to get started, it's hard in modern society to not have heard of the impact of artificial intelligence or AI. This might include both positive and negative connotations about the term. You might not even have an idea what the term means. Instead of thinking of AI as some futuristic robot coming to take everyone's jobs, AI doesn't announce itself. It works quietly in the background on common tasks every day. AI organizes photos on your phone without you having to ask. It makes movie suggestions on Netflix. It reroutes your GPS maps in your car and suggests words that pop up in searches on the internet. Maybe one way to look at AI is to use an analogy. Imagine you're a manager at a large sales company and you get a new intern named Jo. She's fresh out of school, very eager, and during the job interview, you discover she's really good at spotting patterns. You don't give her a job manual with a lot of instructions or rules to follow. Instead, you tell her, here is all the customer information. Go through it and learn who the best customers are. Jo gets to work. She goes through receipts, the purchase records. She takes notes. She works through the night. She never sleeps or eats and never takes a break. Slowly, Jo starts to notice. Customers who shop on Friday afternoons tend to spend more money. Customers who buy the store's most popular item always come back for the matching accessory. And if a customer hasn't bought anything in 3 months, they probably won't be back. At first, Jo's observations are pretty rough, and many of them aren't accurate. However, Jo learns from every mistake, and she looks at more examples, adjusts the observations she's making, keeps getting better at making predictions. After a few months, given a new customer, Jo can with decent accuracy predict whether this customer will buy again, what they might want, and when they show up. Jo has become an invaluable employee for productivity for the company. Plot twist. Jo is AI. All the customer information is the training data. Jo getting better over time is machine learning, and Jo's predictions are the outputs that the AI gives you. With AI as a companion tool, the company is more productive. So AI could be thought of not as a replacement of human thinking, but an enhancement of human thinking. When calculators were invented, people thought that humans would never do math again. But the calculator enhanced our ability to do math. Maybe AI is a calculator for ideas. Whether it was the steam engine, the printing press, electricity, automobiles, the calculator, the computer, and now AI, society learns to adapt to new technology and new tools. So what is artificial intelligence? Let's make some definitions. The acronym AI, or artificial intelligence, is now widely used in a big part of our modern society. Simply put, artificial intelligence attempts to coax a machine, typically a computer, to behave ways humans judge to be intelligent. That's a quote from John McCarthy, a computer scientist in 1950. To think that AI is one thing would be a mistake. AI is an entire field of study, just like physics or chemistry, that encompasses many concepts, some older concepts and some obviously more cutting edge. It simulates, hence the term artificial, the human's brain ability to use heuristics or thinking or intelligence. So the term heuristic just means a method, a shortcut for quick decision making or quick problem solving. Humans use heuristics every day to navigate the world. For example, learning not to touch a hot stove because it might burn us. You've learned many past experiences to create a heuristic to operate within the world we're in now. For machines, they're built, or in the case of computers, programmed to use heuristics to follow a set of instructions, like a recipe, to perform certain tasks. So AI tries to get the machine, the computer, to make quick decisions and solve problems in a way similar to the way that humans do, but theoretically better and faster than us. We are now seeing the use of AI all through our lives, from using search websites like Google to our phones to ChatGPT to smart cars to air traffic control. Literally anywhere there's information, decision making, and problem solving, you can expect AI to start affecting it. So let's now get more specific with our definitions and some basic AI terminology. To understand the concepts, we need these definition of terms in the context of AI that will be used. We'll start with artificial. This term is used because humans create AI. They use the machines, the programming, the computers. It is not natural or biological like a brain. Intelligence is a word humans use to summarize our human experience using our brains, or thinking. But in this context, it refers to the ability to learn new ideas, adapt to new information, apply that knowledge, solve problems, and make decisions using heuristics. Learning is when new information, or data in the case of computers, comes in as an input. We remember that new information, are able to understand it, and eventually apply it. And reason, or reasoning, is where remembered or learned information, or data, is used to help make sense of new data, data we've never encountered before. Patterns is a word you hear that are the connections between the data formed through reason, both in the known data and making connections to the new data not seen before, making that pattern connection. Predictions, or to predict, is the ability to extrapolate new data and create data from the patterns and the learned and remembered data. Problem solving is an ability to take that remembered data that was learned and incorporate the new data through the patterns to solve problems that are expressed through the data. You will identify the problem, examine the cause, define the steps and actions for solutions, and implement that solution. You'll also hear the word model. A model is a system, or a process, or a technique used to simulate or imitate another object. Good example is a map is a model of the Earth. These basic terms will lead to the next section on more AI-specific terms that you will have heard, like machine learning, deep learning, generative models, large language models, neural networks, even the terms ChatGPT, Gemini, Copilot, Claude, etc. So now that we've built that foundation of terminology, let's get into some core concepts of AI. We've established that AI is a field of study that focuses on human programmed models of reasoning heuristics that are similar to the human brain, to learn from existing data, take in new data, to adapt, make decisions, problem solve, and then even extrapolate new data. Within the field of artificial intelligence, we can establish some important terminology. If AI is the broad field, machine learning is a subset of AI. Like thermodynamics is a subset or a subfield of the study of physics. Deep learning is a subset of machine learning, and therefore a smaller subset of the field of AI. And neural networks are used by deep learning models, and thus another subset. So just to show you, when you use the terms, you're speaking within subsets of a larger, broader field. Going into more depth. If artificial is the broad term, machine learning is within a subset, and deep learning is a subset of machine learning. Within deep learning, we have various models of implementation. There are discriminative models. There are generative models. There are large language models, sometimes just expressed as LLMs. Within there, Existing systems like Gemini, ChatGPT, they intersect between the generative and the large language models, but we're going to dive into each of these. Another important concept in AI is the concept of the neural network. A neural network is a machine learning system inspired by the human brain, consisting of interconnected artificial neurons called nodes, or more specifically perceptrons, that are arranged in layers. But we're also going to examine this in more detail. Let's start by examining machine learning. Machine learning can be summarized as using a computer program that takes input data to train a model, and then that trained model can make predictions with new data it's never seen before. Machine learning uses these programmed algorithms to analyze large data sets, to learn, to find patterns, to make informed decisions by improving its performance over time. Some machine learning techniques include supervised learning models, which train or learn on labeled data. That's data with clearly defined output, and examine outputs to match the data. So if we just take a note that that term labeled data consists of raw data, like an image or a text prompt or audio, that has been annotated with meaningful tags or labels. So for example, an image of a dog that's tagged as a dog, an image of a wolf that's labeled as a wolf, that will provide context to the model and meaning. So it's essentially having the answer on the question, so they know the final answer. This process, called data labeling, turns data into input-output pairs. So based on the input, they can match it with the labeled output. The label serves as the correct answer or the output for a given input. But there's also other machine learning techniques like unsupervised learning models. Those train on unlabeled data. So a picture of a dog that's not necessarily labeled as a dog. And the idea is to recognize the patterns or the structure within the data without having the answer right there. So if we look at the chart presented here, income versus job tenure, that's unlabeled raw data on a scatter plot. It's just income and years at a company, just a bunch of data all presented on a scatter plot. Then we can compare that with labeled data. Whereas if we have, say, tip amount versus total bill amount, you'll notice the colors represent picked up versus delivered, excuse me, orders. And this data, which is color coded, is labeled. Excuse me. We also have reinforcement learning, which is a learning technique from psychology, which focuses on training the computer agents with the goal of maximizing a reward signal. So providing rewards or penalties to guide the actions towards a specific goal. The algorithms, the programming in machine learning, uses statistics to find the patterns in the data. And the steps of machine learning can be summarized as follows. 1. Data is fed. It is trained into an algorithm, supervised labeled data or unsupervised unlabeled data. 2. The algorithm will identify patterns and relationships using statistical models and statistics, and it essentially learns from the data. 3. Based on the patterns, the algorithm creates a new machine learning model, or it will modify itself. It will reprogram itself based on those patterns to perform better. 4. This new model is then used to make predictions or decisions on new, unseen data. And 5, as the model gets new data and gets new feedback on how successful or unsuccessful it is, it will refine its performance by going back to step 1 iteratively or in a loop. So the machine learning algorithm is by its very nature iterative in performance. It will continue to perform and relearn from itself. So this leads us now up to the concept of deep learning, which is a subset of machine learning. So since we've just examined machine learning, deep learning uses complex artificial neural networks, and it will train or it will learn on large data sets, supervised, unsupervised, and semi-supervised. The more layers in the neural network, along with the size and the variety of data it trains on, determines how powerful that deep learning model is. Deep learning models can also be divided up into discriminative, generative, and large language models, as we've already stated. Discriminative models learn from the relationship between the labels of data points and can classify those data points, for example, a data set of bank transactions that will label as fraud and not fraud transactions. So the deep learning discriminative model trains on labeled data. Another example might be to train a deep learning discriminative model on a set of pictures of cats and dogs that are labeled cat and labeled dog. Then inputs to the deep learning discriminative model, new data set comes in. For example, a picture of a cat that's unlabeled. And it can predict using probabilities and creating decision boundaries which label to put on this new data. Will it label it a dog? Will it label it not a dog? Based on those patterns and those predictions it creates. Generative models learn the patterns of the training data. And when a generative model is given an input, example, a user prompt, it then generates something new based on the patterns it has learned. For example, in an unlabeled data set, pictures of cats and dogs, the generative model will find the patterns in the pictures of things, patterns that are around cats, patterns around dogs. And then the generative model will use those patterns to create a completely new, it will generate a completely new image of a dog matching the patterns it learned. Large language models, although there is some overlap, large language models and generative AI models are not necessarily the same thing. Large language, or LLMs, are pre-trained with very large sets of data and then fine-tuned for specific purposes. They are pre-trained in text classification, question answering, document summarization, and text generation. This is why when you look at sites like ChatGPT and Gemini, the text-based prompts are really something that's been fine-tuned and trained upon. They then can be fine-tuned for more specific problems. For example, an LLM can be specifically fine-tuned for retail, for finance, for healthcare, even for entertainment. Various AI models are developed and or sold for those specific purposes. For example, in smart car hardware, to websites like Netflix, to hardware like Alexa or Google Home or Apple Watches, for example. The most common AI models, ChatGPT, Gemini, Copilot, Claude, etc., are on that intersection between the large language and the generative models. So large companies that have billions of dollars in resources can train these big LLMs and then sell them to companies with specific data sets for fine-tuning. You can tell if it is not a generative model if the output is 1, a number, 2, a classification like spam or not spam, or 3, a probability. You can tell if it is a generative model if the output is 1, natural language, for example, text coming out or speech, 2, an image, or 3, audio. The generative model generates new data that is similar to the data that it was trained on. Text-to-text models take natural language and produce text output. Gemini, ChatGPT, they're very good at this. Text-to-image. It's trained on large sets of image and can generate new images. Certainly ChatGPT and Gemini can do this, but Midjourney is a maybe better example of this. Text-to-video. So this can generate and edit video, so another step beyond the images. Text to 3D, again, taking another step forward, produce 3D models for gaming assets or 3D printers. And text to task, to perform a specific task or action based on text input. Now, with us having a general understanding of machine and deep learning, we can now go even deeper and examine the neural network. So neural networks is a machine learning system that was inspired by the human brain to learn through training. They are computational models of interconnected layers of nodes, or artificial neurons, or perceptrons, that are arranged in layers that process data. The more layers, the more powerful the model. From an input layer through a series of hidden layers, and finally ending in an output layer. The layers use weighted connections. The weight is the strength of the connection between the nodes, like synapses in our brain that connect the neurons. And the layer performs a mathematical function, passing the data on to the next layer. The next layer then adjusts the weights to recognize intricate patterns, representations, and relationships in large hierarchical data sets. For example, image recognition, fraud detection, natural language processing, and speech recognition. These interconnected nodes form what in computer science we call a graph, with connections between the nodes. Here you see node A connected to node B. Those connections can be directed connections, meaning the information flows one direction. So here in the diagram you see A flows from one direction to B. They can also flow multiple directions. So here you can see node B and node C can both flow to and from each other, whereas the connection from A to B is just one way. These directed connections can also have weights between the nodes. So you can have what's called a weighted directed or weighted undirected graph. The weight is a value given to the connection. So for example, in a map, the weight could represent the time takes to travel between two nodes, or the cost between two nodes. So here in this diagram, you can see the direction between A and B costs 10. It has a weight of 10. The connection from A to C costs 18, but from C back to A costs 20, etc. These interconnected nodes form a graph. The graph has nodes forming layers, including an input layer to take in the initial input, like the prompt you'd type into something like ChatGPT. The data is then passed to a hidden layer, where each node multiplies the input by its corresponding weight and adds them up. So the input weights are summed in the hidden layer. Then the sum passes through what's called an activation function, a nonlinear transformation. It's a mathematical statistical function that essentially decides if the neuron or the node should be activated, or in the case of neurons, fired or not. So once that activation function is applied, it then moves to the next hidden layer. And this process is repeated. And then eventually, the weights are summed and scored again and again, and activations functions applied again and again through the many hidden layers. The data is then passed to each hidden layer in the process, which continues to refine which node or which neuron is active. The weights act like dials. They control the strength and the importance of each input signal, which in turn influences the node's output signal. There are built-in biases, which are values that shift the decision threshold to determine if the nodes in the next layer activate even with weaker input values. So it applies this bias to the nodes as well. The more hidden layers, the deeper the learning. Finally, the last hidden layer passes the data to an output layer, which produces the model's prediction or classification. So in the case of a commonly used LLM like ChatGPT, you type the prompt in the input layer and you read what it generates in the output layer. Weights are summed, they're scored with biases, activation functions are applied to determine which nodes in the next layer are activated, and so on until it reaches the output layer. When the neural networks are trained and data is sent into the input layer, through the hidden layers, and finally to the output layer, the network will learn. After coming through the output layer, error calculations are made to calculate the discrepancies. How accurate was the model between the predicted output and the actual output, or the expected output? This, along with the weights and biases, are then adjusted to retrain the data as it goes through the iteration process. This is simply put as back propagation. In training the model, the neural network, we use the labeled supervised, the unlabeled unsupervised data, and semi-supervised, which is when a small amount of labeled data and a large amount of unlabeled data is used for training, turning that unlabeled data into pseudodata. For example, If we had a bank that was using labeled data that was labeled fraud and not fraud, it will learn with the unlabeled data what it could classify as fraud or pseudo fraud and pseudo not fraud from that unlabeled data set. All right, let's step back and look at the big picture. What is AI and what it isn't? Now that we've taken a deep look at machine learning, deep learning, and neural networks, and we've got this grip on definitions and the core concepts around AI, we can define some things it can and it cannot do, along with some fundamental questions about the impact and where AI is going. Let's start with a simple comparison chart. What is AI good at? Repetitive tasks, spotting patterns in data, sorting information fast, making predictions. What are humans good at? Being creative, not just compiling information. Actually caring about people, not just imitating caring. Asking better questions and making moral decisions based on situational ethics. Here are some myths about where the current state of AI is. So the first myth is that AI is conscious. In reality, AI is math, it's statistics, it's patterns. The next myth is AI can replace all human jobs. The reality is AI can replace tasks, not necessarily whole roles or whole jobs. But that question is a bit more nuanced than that. Next myth is AI is always correct, but there is a big reality that AI can definitely make mistakes and that AI is unbiased. Well, that's a myth. AI learns human biases and it learns human mistakes. It learns through the training data from us, so it can pick up on the same biases and the same mistakes that we make. Even if this could be challenged, so maybe we should add a few more points about the theory of AI and 3 specific classifications of AI. So this is more on the philosophy of AI. So we can talk about something called narrow AI. This is the AI we currently have in the world. It can be defined or described as AI that is good at one specific job or one specific task. So I would put ChatGPT, Gemini, Siri, Alexa, Netflix, Face ID, all of that in the category of narrow AI that is good at one specific task. Moving forward, there is the idea of general AI. We don't have that. It does not exist yet. Sometimes this can be described as AGI, or artificial general intelligence, representing the idea of machine learnings or AI that can learn anything, not just one task, but every task, essentially reproducing human intelligence, but in an artificial state. So the general AI, in terms of like a machine being able to operate as intelligently as a human, does not yet exist. And then beyond that, philosophically, we could talk about super AI, which is pure speculation. It's this theory that could be described as AI that surpasses the human intelligence, solving problems that we can't even imagine, reshaping our society. This some feel is in the realm of science fiction. For example, The Matrix or HAL 9000 from movies and fiction. So let's circle back and address some of those big questions everyone's talking about. Is AI going to take my job? Is AI going to take over the world? Is AI really alive? They're complex and nuanced questions, and the answers are not simple. But some of them can be debated, but here's my opinion. For the last two, is AI going to take over the world? Is it really alive? Well, we haven't reached AGI yet. Never mind super AI. So I would answer no. AI is definitely not alive, not in the sense that we describe alive. It's not going to take over the world in the dystopian sense we might imagine. So I would have to give a no to those two answers. But as far as the first question goes, is it going to take my job? Well, it is taking over tasks now. We're living in a time of change, and AI is driving that change. So it's not a simple yes or no answer to is it going to take my job? It's certainly going to change jobs. Thank you. Thank you for your attention on this presentation, and thank you for learning about what AI is. Have a great day.